Guys, in this video, we're going to talk about rational exponents. In the previous videos, we talked about exponents where the powers were whole numbers. There were no fractions there. But here in this case, we're going to deal with fractions as well. Before we do that, we need to learn a term called radicals. You've seen this before, square root of 25. Square root of 25, that is this way of writing with this symbol, is called a radical. You can have the cube root of 125. You see that 3 outside? That means it's a cube root. And for the power fourth root, we put a 4 there. You get the idea. For 5, 6, 7, whatever root you want to find, you're going to do that. To evaluate square root of 25, we can think of this as 5 times 5. And by the way, you can put a 2 here if you like, or you don't have to. And if you put a 2, it still means it's a square root. It is just because its square root is so common, we don't put the 2 there. So when there are two 5s for a square root, we just take 1 5 as the answer. For the cube root, 125 is 5 times 5 times 5. And so in this case, because there's a cube root, there are 3 of these 5s, we just take 1 of them. In the case of the fourth root of 16, 16 can be written as 2 times 2 times 2 times 2. And because it is the fourth root, and there are 4 of these, we're going to take 1 of them. What about this example here? So you can write negative 8 as negative 2 times negative 2 times negative 2. It is a cube root, which means for every 3, I'm going to take 1. What about square root of 81? The fourth root of 81. So 81 can be written as 3 times 3 times 3 times 3. And there are 4 of them. Because it is a fourth root, for every 4, we take 1. Now we come to this one here, square root of a negative 4. If you try putting it into a calculator, you're going to get a math error, error 1, undefined, and many other error messages depending upon your calculator. And that is because this negative 4 cannot be written, for example, here, the negative 4, you can never write a negative 4 as two identical numbers. That is, you can never write this as 2 times negative 2 times negative 2. It's not equal to that. It is not equal to positive 2 times positive 2 either. So which means you can never really find the square root of a negative number. In the same way, you cannot find the square root of the fourth root of a negative number as well. This stands for DNE stands for does not exist. It is the same problem. So in general, when these numbers are even numbers, we cannot find square root of negative numbers right there. A very important fact for you to remember. So whenever we try to find an even root to the power square root of 2, fourth root, sixth root, eighth root, 10th root, we cannot possibly find the root of a negative number for those. In general, you write the nth root. N stands for a number, an integer number, 2, 3, 4, 5, 6. Oh, by the way, a positive integer number. And that stands for the nth root. Now, this way of writing, again, to remind you, this way of writing is called a radical. There's another way of writing the same thing. For example, I could have written the square root of 25 like that in this form, 5 to the power of 1 over 2. Now, this form is called the rational form. So, 25 to the power of half. And I could have written a previous example, say the fourth root of 16 the fourth root of 16 as 16 to the 1 4. Notice here the square root has a 2, the fourth root has a 4 in the denominator. The answers are exactly like the same as before, no difference. So if you have 64 1/3, this is the same thing as the cube root of 64, and the answer is 4. Why is it 4? Because 64 can be written as 4 times 4 times 4. And for every 3 of those, you take one of those. In the same way here, you can do the fifth root of negative 32, and your answer will be a negative 2. Why is that true? Because negative 32 is negative 2, negative 2, negative 2, negative 2, negative 2. Okay, you're multiplying it 5 times over. Here, the square root of a negative number, this is the same thing as a square root of negative number. As we talked before, when these numbers here, they are even, 1 over 2, 1 over 4, 1 over 6, 1 over 8, and so on. And if we have a negative number of those, it does not exist, D&E. Finally, how do we combine the two? For example, if I want to evaluate, say, 16 to the power of 3 over 2. Let's look at it for a second. This number is the root. The top number is the power, which means you can do one after the other. So you can write this as 16 to the power of half. Okay, so that is the square root. Then you can write the power outside. So calculate the bracket first. The square root of 16 is a 4, and you have to the power 3 there. So this is the same thing as 4 times 4 times 4, which will be a 64. One more example. 20, okay, let's do 27 to the power of 2 over 3. So you can write this as 27, the cube root there, and the power there. And what do we have here? We have the cube root of 27 is a 3. That is 27 is 3 times 3 times 3. And you have a square there. And then what you can do now is 3 to the power of 2 is a 9. The same kind of example can work for negative powers as well. So let's use the same thing we have here. 27 to the power of 3 over 2. So write it exactly the same way as before. I'm sorry, guys, I wrote it upside down. So let me correct myself. So we have 27 to the power of negative 2 over 3. So I'm going to write 27 to the power of 1/3. Okay, 1/3. And outside on the bracket, this time it's going to be a negative 2. So we have 27 to the power of 1/3 is 3. And then we have 3 to the power of negative 2. And in the previous videos, we saw that when you have a negative exponent, you can take it down to the denominator and write it as a positive exponent. And the final answer would be 1 over 9. If you need to, you may want to watch these videos a couple of times till you get a full handle on this, and also make some good notes so that you can solve the problems that you get. See you in the next video.